Hello again and welcome to another video from Berkshire Guitar Amplifier Repairs. Stuart Smith on the bench. We've got a Fender Music Man HD130 in today. Far too big for me to lift up on the bench, so let's have a quick look at it now. Well, here we are with the Music Man HD130. As you can see, very Fender looking amplifier. I've hardly seen any of these. I think I might have seen one in the past. These were from the mid to late 70s, and apparently they were designed by an ex-Fender man called Tom Walker, and they formed a Music Man company in 1974, and also Leo Fender himself joined the company, so I don't know the history on that. Not sure what happened there, but anyway, this was a Leo Fender, and hence it looks amazingly like a Fender. I'm quite surprised they were able to get away with this on copyright grounds, but I don't know the legals on that. Anyway, the problem with this amp is he says that he bought it quite recently, I think from a chap on eBay, and he played it a bit and then it just fizzled and died. Now I've powered this up now, and I've played it for an hour, and it's completely solid, nothing wrong with it whatsoever. And it sounds very nice too. So I'm going to take the chassis out, get it up on the bench, and we'll have a look-see to see if we can see why this might have failed. Okay, here we are inside this amp. The first time I've been inside one of these. Haven't had one before. Quite interesting. Haven't looked at the schematic, so I'm taking a guess. My guess is that might be the bias board there. Not sure. We've got a pot there. That could be bias. And then look, we've got a combination here of transistor. These are all transistors. I think those are diodes of some sort. Oh no, they're the diodes. They look like those big stud diodes for a moment. They are, of course, the phono plugs coming in, probably from the. Oh no, I don't know what that is actually. No, just feeling underneath. Oh yes, those are the phono plugs, probably to the reverb. More transistors here. Look, transistor. And then here we have the power valves, so we have a transistor preamp and then 4 power valves here. Not sure what these great big resistors are. Surely it's not cathode biased. 1K5. Could be cathode biased. Need to have a look at that. And then we've got this board here. I mean, at first glance this looked like a regulator board to me, plus or minus 15 volts, but I don't recognise these transistors here. So it could be, we've got a couple of diodes here. I guess they could be Zenas with a bit of smoothing. Maybe we've got a plus or minus 15 because we've got a dual op amp here, an MC1458, 2 741s in one package. So maybe this is a plus or minus 15 for the op amps. A lot of work, isn't it, to produce, you know, this just for one op amp, if that's what they're doing. Be interested to look at the schematic on this. Okay, so along the front it's very Fender-like. Here we go. And yeah, it looks exactly like a Fender Twin or something, doesn't it? Got tremolo, intensity, reverb, 2 channels, vibrato channel and a ordinary channel. Exactly like a Fender. Right, I think we'll flip it over and have a quick look at the under the dog kennel on the top to see what the capacitors are like. These are all original, these electrolytics, 1, 2, all these here and these here. This is 1970s, so these are kind of past their sell by date, but as ever I will see what the customer wants to do. I think basically let's see if we can get it going first and then look at what we want to do. These are quite nice, these capacitors. Flat. Yeah, they're not round or anything. I'm not totally convinced I've ever seen any capacitors like that either. Normally they're round. So it's quite neat, quite neatly done this, and it's quite clean inside here. So let's flip it over and have a look on the other side. So here we are under the old dog kennel, and these look original capacitors to me. Mallory, 100 microfarad, 450 volts, giant things. don't like the look of them particularly. Look, bit of bulging there, and a bit of sort of dryness looking around the connection there. And on this one here, again, a bit of a bulge there, and a bit of sort of dryness around where that joins there. So these are sort of on their way out, if not gone. These two 20 microfarads 450 volts don't look too bad. Can't see any evidence there of any problems. So that's the situation there. And on top we have mains transformer, probably reverb transformer, although a bit surprised because that's reverb's transistor. Not sure. Output transformer and 4 EL34s. I love it when they have these clips here, but they're not actually held in by the clips. The clips are just completely loose, which you see quite often on amps. To overcome that, you just grab hold of the clip like that and bend it up tight like that, and that will now grip the valve. None of these are being held in by the clips. These are ancient. These are the original Mullard EL34s that came with this amp. So again, they are, you know, almost certainly requiring to be changed. But I think what I'd like to do is to diagnose why the amp isn't working first of all, and actually first of all make sure it isn't working. We haven't even tried that, and then see if we can just find the fault first of all, and then think about what we want to do in terms of upgrading, if anything. The other thing I notice is this has a non-standard UK plug on, so this needs changing. Nowadays we have a shroud. This is all plastic from here to here to stop you putting your fingers in like that and pulling the plug out. So that's got to be changed. Right, so there we go. I'm going to turn it on now and see if I can get anything out of it. Okay, here we go. The switch is for the middle off position, high and low power. So let's go to low. The light comes on, always a good sign. I think I'll just pop an input signal in there on my signal generator. See if we can get any life out of it. Absolutely nothing. Very, very dead. Faintest of faint hums coming out of the speaker. And we've got a signal going in, yep. Bit high frequency that, just turn it down. I can just hear something there. Really, really faint. Let's try the other channel. Exactly the same. So the very first thing to do would be to see if we have any HT. Always a good thing to have. Okie dokie, let's see what we've got, if anything, on the old HT side of things. So just have a little dab around the power valves really. Nothing. That's why the amp's not working. No HT. So that will be the reason. So do we have an HT fuse on this amp? Let me just have a quick look at the back. There is a fuse on the back. That's the mains fuse there. So I think we'll find that it's got 240 volts AC on it. Just check. Yep, so that's the mains fuse here. Have we got an HT fuse in this thing? Okay, right, just found there's a standby switch on the back here. So that was off. So I'm going to turn the signal down and take it out of standby. Okay, I can hear much more noise coming out of the speaker now. And when I turn it up, the signal's there. Okay, so the complaint on this was that it didn't work at all. In other words, it was completely dead. Surely he knew about the standby switch. That works nicely. Sounds nice, this amp. All those controls work okay. Let's try the tremolo channel. Ooh, nice. This is a story about an old Music Man amplifier. Came to me, owner claimed it wasn't working, but I found out differently. Seems okay. Yeah, master. Lovely sounding amp. Bit scratchy, that pop. I hate to say it about a transistor front end. Sounds absolutely gorgeous. Alrighty then, so right, let's have a little think. We have an amp that's basically working. I don't know if the valves are matched, if the bias is any good, or what's happening really. Obviously some caps could do with replacing. Basically working sounds good though. So I think I'm going to have to speak to the customer and find out what he wants me to do, because he said the amp made a horrible loud crackling sound and then died on him. Just going to give the power valves a tap. I will test those valves, make sure they're okay. So there's nothing there. I'll just have a little tap around here too. That all seems good. Well, I think I'll leave it on for a little while just in case it falls over, and then give the customer a call, see what he wants to do. I'll catch you later. Okay, here we are back again a day later. I thought I'd test the valves, so I've taken all 4 valves out and tested them on my tester. 3 were good and 1 was very bad, so I substituted it for a second-hand valve I had in my stash, which was sort of similar. The customer doesn't want to spend out on a new set of valves at the moment. But we have a problem here because I've got the bias meters on 2 of these, and look what we've got. We've got 5.2 milliamps on one, 2 milliamps on the other, and insane HT, 645 volts, absolutely bonkers. I'd like to see what the voltage is across these HT caps here, because they're only rated at 450 volts. Maybe that they're in series. The fact that they're 100 microfarads leads me to believe they might be in series with a sort of resulting capacitance of 50 microfarads at 900 volts. So this is absolutely mad. Now it might be that there's a bias control inside and that the bias is turned way down or something, but this amp as supplied, he bought it off eBay, is totally unbiased at the moment. I think I will just quickly swap the meters into the middle positions here just to make sure that this that's a very interesting noise. The amp started oscillating when I turned it off. And then just make sure it's not something to do with these outside positions or whatever. Make sure we get a similar kind of reading in the middle here. Let's do that. And here we are, valves in the middle position, absolutely identical bias currents. So obviously the very first thing to do is to flip it over and see what the state of the bias control is. Might be able to get this to bias up just on the pot, I don't know. I'll also stick a meter across here to see what's across each of these 2 caps here. Yeah, we've got 350 volts across each of these, so 700 volts across the two. Insanely high HT on this. There you go, and just stopped oscillating. Right, so let's see if there is a bias control we can twiddle. Okay, not having much luck here. We've got 3 trim pots here, this one, and this one here. That one doesn't do anything, I can see on the bias side. It might be some sort of hum balance. I don't know what these 2 resistors here are. This one doesn't do anything either, to the bias anyway, and the fact that it's kind of down in this transistor area makes me think it's something more to do with balancing some transistors. And then we've got this thing here, which has a dramatic effect on the voltage on this pair of valves. It goes down to about 200 volts if I so much as touch that, and doesn't affect the voltage on this 640 at all, so I have no idea what this is doing either. So unfortunately I'm going to need to get technical and just have a look at the schematic and see what the heck's going on here, because there's no obvious bias control that I can see. Right, the plot thickens on this amp. We're in a little bit of trouble really. First of all, these aren't transistors, they are operational amplifiers. I wondered why I couldn't find a circuit with transistors in it. All I could find was a circuit with loads of op amps. And of course, on looking at these are 7-pin or whatever, 7-lead socketed op amps. They don't have any writing on them. But anyway, that's what they are. And there's another op amp here. I did manage to get a schematic, but it's really poor. It's hand drawn. This is the original schematic. So hand drawn, not even properly printed out. And you can't read half the writing and values. It's very weirdly drawn as well, with all the valves upside down, and it's just a nightmare. And also I just couldn't make head or tail of it, because I'm getting 15 volts, plus 15 volts on the pin 5s here. And I thought, well, that's not right, that can't possibly be right. We should be looking at minus 30 or something. And then when I delve deeper, this has got an extremely weird circuit to it, which to be honest with you I don't really understand, particularly as the diagram's so poorly driven. And it's to do with this little lot here. These 2 power transistors sit in the cathodes of a pair of power valves, one for each pair of valves. And it looks like they're putting the drive signal into the cathodes. This is somehow cathode driven. In other words, you hold the grid steady and waggle the cathode up and down, which you can do. Of course, there's no kind of real difference between holding the cathode steady and waggling the grid up and down, but that's what they do. I've never seen it before. But also these set the bias and everything. It's all extremely complicated, so I didn't want to get too involved. Fortunately, I managed to find a kind of a crib sheet about how to bias this, and by bias I mean setting up the bias across these resistors here, I think using this trim pot. So we're going to have a go at this and see if we can just bias it according to these instructions. It sounds okay, so my guess is maybe it's meant to run at that low current. I just don't know. I can't find too much more about it. Anyway, let's see if these instructions can be pressed into service. We're looking at these 3.9 ohm emitter resistors, which I suspect are these here, look. So I think we measure across those and adjust the trim pot TR1, which I assume is this trim pot here. Obviously it's not marked. It wouldn't be so crazy to actually mark up anything, but my guess is it must be that. And read 25 millivolts across the 3.9 ohm emitter resistors. If there's a difference in voltage between the two, set the lower of the two to 25 millivolts, and the higher of the two should not exceed 55 millivolts. So there you go. I'm going to set this up so that we can measure across here and just see what we've got, see if we're anywhere in the right ballpark. Because strangely enough, the amp sounds okay, even with that 4 milliamp current, so I don't really know. Anyway, let's get that set up. Okie dokie, I've got the meter clipped across one of those 3.9 ohm resistors, and I'll turn it on. 1.5 millivolts at the moment, but I suspect that might change as the valves warm up. As I say, I don't really know how this bias circuit's working. It's quite complicated. Why they've done it like this, I have no idea. Okay, that's coming up. That's quite high. I'll turn this down a bit. It said 25 millivolts, didn't it? So I'll turn this down. That seems to be coming down quite nicely. Okay, that's 24 millivolts. Let's see what the other one is doing. 10. Quite a big difference between these. Well, it did say so long as the other one's not more than 25 millivolts. If there's a difference in voltage, set the lower of the two to 25 millivolts. The higher of the two should not exceed 55 millivolts. Okay, so the lower of the two is this one. So let's turn that up. I think we might as well split the difference here and go to 20 millivolts. And the higher of the two, which is this one here, oh, that's 33, should not exceed 55. Oh, that's good. Okay, we'll come up a bit more on this one then. So there we are, 19. Let's make this 25 then. There we go, 24.6 nearest, damn it. And check this one isn't in excess of 55, which it isn't, it's 40. So I'm going to say that's job done. That's how they tell you to bias it, that's how I've biased it. I've no idea why it's only got a handful of milliamps going through the actual tube. Ours is not to reason why. Sounds okay. Very loud too. And we're on low there. So there's a 3-position switch just out of sight here, which says off, which turns the power off, high and low. And what happens in the high position, it puts like 700 volts across these tubes. Completely mad, I'll tell you why in a minute. Whereas when you put it in the low position, it puts 500 and something volts across. And even that's very high in my view. So I think we'll leave this in the low position, and I'll tell the client to leave it in the low position. Why is it mad to put 700 volts? Because these tubes can't take that kind of voltage. They flash over. I've seen these EL34s flash over at 500 volts, let alone 700 volts. And the only tubes I know that will just about take that kind of voltage are the Marshall EL34s. I don't know anything about these mullards that are in here. But in general, that's way too high a voltage to have across the tube, in my view, anyway. And of course, why do they do that? Because they want to get more power out of the amp. In fact, this is called a 130 HD. I haven't checked it, but my guess is it's sold as a 130 watt amplifier. Well, how do you get 130 watts out of 4 EL34s? You put insanely high plate voltages on them, and that's what they've done, which I don't think is a good idea. Right, so I'm going to call that job done on that. And we are going to change the HT caps because the customer wants those done, and I think that's a good idea. Plus he's not going to have the rest of these caps done. He's a little bit short of cash at the moment, and he's not going to have new valves. As I say, I've tested them, and yeah, they're okay. Not brilliantly matched, but they'll limp on a bit longer. Just whilst we're here, let's see what voltage is on this, on the anode here. So we've got 500 volts on the anode, look, of these EL34s. And if I put it into the high mode, that's like 690 volts. Absolutely insane. Low mode, 500. So 500 is more than enough. Right, so next job is to turn it off, let it cool down, unplug it, and we will flip it over and change those HT caps. So I've got some in stock, which is good. Got some nice 100 microfarad 500 volts. At the moment 100 microfarad 450. And we'll pop those in and do the other two caps as well, and then this will be good to go. Here are the caps we're going to be changing, these two and these two. These two are in series. I looked on the schematic, and they don't have a balancing resistors between them, across them, like 220k resistors across them. That's again not good design, very poor design. And again, look at these, how loose they are. Isn't that poor? I mean, they are held down a bit by this, but Anyway, we're going to put a 220k resistor across each of these, just to make sure that. Why do we do that? Well, because let me just sketch out the diagram for you. At the moment, we've got cap 1, cap 2, ground. So whatever you want, say 700 volts there. And this should be 350, shouldn't it? It should be, but you're relying on the kind of internal resistance of these caps being exactly the same. And they often they're not, particularly as they age, and you find this drifts up to 420 or something, and this one's got less voltage, this one's got more voltage across it. So what we do is we just put a couple of resistors like this, one there, one there, and that's usually like 220k or something. They don't pull much current, and that forces this point here to halfway to 350, and takes out any of the imbalance in these caps. So we'll put those two in. That's just good practice, and whoever designed this circuit is just exceptionally poor practice not to do that. So you do wonder, don't you? It does save 20p, I guess. So there you go, a couple of 220k resistors. What wattage should they be? Well, get used to doing a bit of Ohm's law yourself, and checking out these things for yourself. So we want a power which is V squared over R. Let's get the calculator. So V is 350 volts roughly, so V squared is 350 times 350. Divide 220, 220,123, 220k is half a watt. Look, so there you go. Half a watt resistor is half a watt power is what's going to be taken, and we've got ourselves some 2 watt resistors here, so they're absolutely fine for what we want. And just before we change those caps, I thought I'd just give you a quick look at what I think is going on in this amp. So here's like a conventional output stage. We have a power output valve here, and HT comes in through the output transformer to the anode, and obviously if this waggles up and down, it couples into here and the speaker moves in and out. So that's how that works. Here's the heater, we don't worry about that. Here's the cathode, which is normally grounded, and then we apply a minus voltage bias onto the grid here, typically minus 35 volts or something like that, DC, to hold the grid negative with respect to the cathode. And then we put our AC signal in here, up and down, coupled via a capacitor, which takes this more or less negative, to minus 34, minus 37, minus 34, minus 37 sort of thing, which varies the voltage on the grid, which varies the current through the valve, which varies the current through here, and couples to the transformer. That's absolutely standard, and our bias is changing this DC voltage here to get the tick over current through this valve to be what we want it to be. Usually a little trim pot on here, adjust the bias to minus 36 volts, the current goes down, adjust it to minus 34 volts, the current goes up, and we just adjust the bias until the tick over current is what we want. DC we're talking now, and then when we apply the AC signal, that current varies. That's a standard thing. Now they haven't done that on this amp for God knows what reasons. I expect somebody will tell me. And instead they've done this kind of arrangement. This is just a kind of block diagram. I don't mean it to be exactly accurate. So same old thing here. HT comes through the output transformer to the anode, but in this case they hold the grid at a positive voltage, in this case 15 volts, just clamped to 15 volts DC. There's no AC coming in here at all. They then take the cathode, instead of down to ground, they take it via some sort of transistor arrangement, some sort of FET or something, via some resistor to ground, and then they put the signal into the FET, so that the FET is now turning off and on and controlling the current this way. You could do the same thing with transistors. It's called common base and common emitter and that sort of thing. I've never really come across it in a guitar amp before. No idea why they decided to do this. Overly complicated. You have these FETs mounted to heat sinks with all their associated circuitry. I've simplified it here. It's much more complicated than this, and that's how they're doing it in this amp. As I say, no idea what the thought is behind that. So we can't kind of bias this amp in a traditional way. Anyway, that's as far as I know, and as far as I'm kind of willing to go, without spending hours looking into this design and working out exactly what's going on. And the circuit diagram, the schematic, is terrible. You can only just see what's going on here. It's hand-drawn, crowded. It's absolutely dreadful, actually. Done by a kid with a crayon. And that's the actual original circuit diagram too. Anyway, so there you go. I thought you'd be interested to know kind of what's going on with this amp. So let's mush on and change these capacitors out, and then we're going to put this one to bed. So the first thing we'll do is just check that these capacitors are discharged. Even after a couple of days they can give you a little bite. Yep, that's all good. Then I'm just going to cut them out like this. It might leave some useful tails for us to hook onto. I'm not quite sure how I'm going to do this yet. I'll just get rid of these. Great big hefty old thing. Mallory. And you know, it's not leaking with a capital L, but this is bulging here. And I don't really like the look of that around there particularly. Yeah, they're probably okay for another 5 years, who knows. But we may as well do them at some point. They would have to be done. They're now, like, I don't know, 50 years old or something. See, that one's slightly worse around there, look, see? And there's quite a big bulge there. Yeah, I think they're probably okay, but let's change them out. Again, we'll do the same with these. We're not going to reuse these, so we're not worried about chopping them short like this. There we go. Again, 2 Mallories, and yeah, they're looking okay, those, but again, best to change them. They're quite old. Right, so I'm going to get myself a couple of 22 microfarads at 450 volts, and we may as well do these first. There are lots of different ways of sticking these caps down. Hot melt glue or silicone. I'm going to use today a couple of these little double-sided sticky pads, which are very good. Give it a little bit of cushioning and also stop it from bouncing around. So we're going to put one there like that, like so. Negative down, negative down. Keep the writing uppermost, look, so that people can, in the future, can read the value there. Don't be putting caps in like this, very annoying. Like so. And now I can connect these to the tails that are left sticking up here by just wrapping each one round and making a little D hook on there, and that'll be quite successful little anchoring job there, rather than try to get it down into the eyelet board again, which is always a little bit difficult. Again, lots of different ways of doing it, depending. So typically I would just cut that short. Then I'll just do one for you. Bend this round like this. Crimp it tight. Maybe even just bend that over a little bit if you want. Make sure that black lead is out the way. How are things looking for your flight? Can be a little bit awkward, that, but it's worth doing nicely. And we're going to solder that, and that's one done, and I'll just go and do the others exactly the same. There we go, perfect. So let's finish off those other 3 connections, and then we can move on to doing this. And here's the last joint going in. So those 2 are now in. Just double check my little diagram. Both positives are up. Yes, both positives are up. Good. Right, now we're going to replace this great big capacitor here with a modern equivalent, which is this. And a lot smaller, look. So that's quite good, because that I think allows us to put, just have a little think about how we do this. We need these resistors across here like this. One from there to there. I think I'll put the resistors in the middle, like this somehow. I haven't quite worked out how to do that yet. And then we can put the capacitors kind of like that somehow. So that's how we're going to go about doing that. Let's do they're quite a long run, these resistors, a bit too long to do that actually. I'm going to have to extend them. I suppose we could also do this kind of thing. I don't like doing that very much. Let me have a think. Okay, I've made a start on this by hooking these resistors round the base of these wires here. And just solder those in so they're I want to solder that for some reason. There we go. So those are in, and now we just have to work out how we get them up to here. Unfortunately, I think we're going to have to extend these wires here. Shame that, another inch and we would have been okay there. Again, lots of different ways of doing this, but I'm just going to take a little bit of tinned copper wire like this and wrap it round to make myself a couple of little extensions. Like so. And we can trim off these bits of excess here. And now our resistors are long enough to wrap around here and solder like that. Make them look pretty. There we go. So those are our balancing resistors in, and if you remember, they just make sure that the voltage across each of those HT electrolytics is the same, i.e. 50% of the total voltage. So now we can put one cap in there like that, and one cap in there like this, remembering that the positive goes here and the positive goes here because they're in series, and then we can solder those to there. So good. Let's get a couple of pads down for these, and we're getting close to finishing. So there we go, a couple of pads down. Not totally essential, just a little extra nicety really. The reason it's not sort of super essential is they're anchored very well by their leads anyway, but we do have this dog kennel lid here which does hold them in to a certain extent. But anyway, this makes things nice and firm. So again, writing uppermost, double check your polarity, positive to the right, positive to the left. On this particular one I made a little sketch to remind myself, and now we can just solder these here, here and here, and I won't bore you with watching me do that. So there we go. And there we go, everything put in now quite nicely, quite happy with that, looks good. And just a final check on polarities, positive, positive, negative, positive, positive, negative, that's correct. I'm going to fire it up and just put a voltmeter on there, but I know it's going to be okay, so let's do that, and then we can put the lid back on. So we should have about 350 volts across here. We have 340, look, and we should have identical voltage across here, and we have minus 340. So those two resistors there are doing their job perfectly, and across here I'm guessing we've got, I don't know, what, 350 or something, 340 across there, and maybe a bit less across here due to this dropper resistor. Oh no, same, okay, 340. So there we go, good. That's all okay. We can put the dog kennel back on, like so, and do a final test on the amp and put it back together. And the other thing we have to do, of course, is to change this mains plug, because it's not standard. Let's have a quick look what's going on inside here. Right, well, it's a 5 amp fuse, which is good. 3 or 5 amps are right in there. And I'm going to throw this plug away, but just out of interest, no, they're all nice and tight, so there wasn't any actual safety issue with that plug. I'll just pop a new one on there. So I had a sort of sudden thought that the plate voltage I'm measuring here is a bit higher than is the actual voltage across the valve, because we've got that FET arrangement in the cathode isn't grounded. So I remeasured the voltages on this cathode to anode right on the valve base, and we're getting about 450 volts on the low setting, so that's okay, 450 volts. I wouldn't really want to go much higher than that, but when I go to the high setting it's 650 volts, so we're putting 650 volts cathode to anode on these EL34s, which in my view exceeds the normal kind of voltage limitations of those valves. So I don't really understand what they've done with this amp. Can't say I like it very much, to be honest with you. Anyway, there you go. So we're good to go on that. I'm just going to plug the guitar in and make sure it's still working. I can hear reassuring noises from it. Yeah, that's working okay. We'll go into the vibrato input. I have to say it sounds absolutely gorgeous though, having just been negative about it. Really lovely. That's a nice sounding amp. Right, there you go. We'll turn it off and call that a wrap and put it all back together. Okay, well there we go. Turned out to be, relatively simple job. We did the HT caps, which needed doing. He didn't want to do the other electrolytic capacitors, and he didn't want a new set of valves. Valves are very expensive at the moment, and I don't think he's particularly wanting to spend a huge amount on the amp for reasons that I don't get involved with. So we did a sort of half a job in the end. But the amp works, it sounds lovely, and there's no sign of that fault that he said when he got it, played it for a bit. It kind of fizzled, crackled and died. Now whether that will come back again to haunt him, I don't know. If so, I'll have to have another look at it. But I've banged it around quite a lot. I've played it for a couple of hours. It's been on for maybe 4, 5, 6 hours in total, with not any indication whatsoever of a solid failure like that, so I don't know. It's not gig critical, he plays it occasionally at home, so if it does go wrong again, it's not the end of the world. Well, there you go. I hope you enjoyed looking inside this fairly rare amp. I think I've seen one before in all the time I've been doing this. And yeah, quite an interesting amp, as I say, very Fender-like. Anyway, I hope you enjoyed it, and I'll catch you on the next video.